Hi, welcome back to another episode of Algebra in Words, the video series on YouTube. In this video, we're going to continue our discussion on radicals, and specifically, we're going to be looking at rational exponents. If you want to follow along in written form with a few examples of what we're going to go over here, you could find them in page 58 of my book, Algebra in Words, which is on Amazon, and you can find the link to that in the description box below. So let's get started. What I have on the board is a basic explanation of how to convert a radical into a rational exponent. What is a rational exponent? Well, let's break down the words. The first word is rational, which has the root word ratio. That's a fraction. And that means a fraction in the exponent. But specifically, where does the numerator come from? Where does the denominator come from? It's easy. Let's look at a radical where we have the base, the root, and the power. And again, remember that that's interchangeable, where the power can either be under the radical or outside the whole thing in parentheses. They're both interchangeable. Now, again, it's easy. Take the base from either example and put the base, and then you have a fraction. What goes in the numerator? The power goes in the numerator, and the root goes in the denominator. It's as easy as that. I have one basic example here where we have the cube root of x squared. And if we were to convert that into rational exponent form, the power goes in the numerator, the root goes in the denominator, and you would have x to the 2/3. And likewise, you could go in either direction. You could be given a base with a rational exponent and reconvert it, or just convert it back into radical form. So I'm going to erase this, and then we're going to look at a few examples. The first one we have is 10 to the 1/2, and we're going to convert that into a radical. So let's write the radical and write the base, which is 10. And now, what goes in the root and what is the power? Well, let's start at the top. The numerator is the power. That's 1. You could write the 1, and I'm going to write it, but generally we don't have to write the power of 1. But for now, I wrote it just for exemplary purposes. And then what is the denominator? It's 2. The denominator is the root. That would be here. And I'm not going to write the 2 because we don't usually write root 2. You could, it's not wrong, but generally we don't. So I'm going to leave it like this. Actually, I'm going to even erase the 1 so that it looks most like you would have, like you would see it in a book. Okay, let's look at the next example. We have x to the 3/2, and we're going to convert that to a radical. X is the base. That goes here. I drew the radical. The numerator is the power, that's 3. And the root is 2, which once again would be there. And when we have square root or root 2, it's unwritten, so we don't write the 2. And let's look at the third one. B to the negative 3/4. Now, one difference here is there's a negative in the exponent, and we'll address that accordingly. Let's first sort out the base, which is b, and the power, which is, for now I'm not going to apply the negative yet. Let's write 3 for the power, and the denominator 4 is the root, but we still have a negative that we have to address. So if you remember, how do you address a negative exponent? You address it by moving the term to the factor to the opposite part of the fraction, and then change the sign of the exponent. So since this whole thing you can think of as being over unwritten 1, except I wrote it, to change the negative to a positive, you would move this whole factor to the opposite part of the fraction, which would be the denominator. And if we were to do that, it would be like putting all of this under 1. And once we do that, in summary, b to the negative 3/4 equals 1 over the 4th root of b cubed. So I'm going to pause this and we're going to look at a couple more examples. Let's look at the next examples. The first one is the cube root of x. And in these examples, we're going to convert from radical to rational exponent. So first, let's write the base x. And now let's start with the power of the rational exponent, which would be, it's an unwritten 1. So even when you don't see an actual exponent written, assume it to be 1 and put 1 in the numerator. And finally, what is the root? It's 3, and that will be the denominator of the rational exponent. So in summary, the cube root of 3 converted to a rational exponent is x to the 1/3. Pretty easy. Let's look at the next one. The square root of now a binomial, y minus 3. Now, if you remember way back from order of operations, that even a radicand counts as a group. And that matters in a case like now because basically I would just recommend that when you have to move the whole radical somewhere else, do it with parentheses around it. So basically, let's start by writing the base in parentheses, y minus 3. And now, what will be the numerator and denominator of the rational exponent? Well, we have an unwritten power of 1, so the numerator will be 1. And what is the root? The root is unwritten 2, so it will be 2. And the problem is done. The square root of y minus 3 equals the quantity y minus 3 raised to the power of 1/2. And finally, of these 3 examples, let's look at the last one. 1 over the cube root of x minus 3. So let's just do step by step. First, let's start by writing the base by itself. And remember, we'll put that in parentheses. So x minus 3. That's in parentheses. And now let's apply the numerator. And just looking at this for now, the numerator is, since it's unwritten 1, we'll write 1. And we know that the root is 3. That will be the denominator, so that will be here. But finally, remember that since this whole thing, or at least this part, is over 1, then that means that the sign of the rational exponent needs to be negative because it's in the denominator. And if we were to go in the reverse, moving this to the bottom would be, to get rid of the negative sign, we would have to move it to the bottom to get rid of the negative sign. So anyway, that concludes these examples, and let me erase this and put a few more on. I have 3 more examples on the board, and in these examples, they start in rational exponent form, and we basically want to evaluate these now, meaning basically to solve them or simplify them down as much as possible. Now, in cases like this, and usually the problems that you'll deal with later, they'll be mixed, meaning mixed with numbers and variables. But in these examples, it's just numbers. So what I want to say is, since we'll be evaluating, my recommended strategy is to apply the denominator, meaning the root, first, and then the numerator, or the exponent, last. Finally, if there's a negative in the exponent, you can adjust for that either in the beginning or the end. When we get to the second example, I'll tell you what I recommend to do for that. So let's start with the top one. Another recommended thing, also just a general rule of thumb, is if you're given a fraction like this one, you may consider trying to, and really you should always try to reduce the fraction as much as possible in the beginning. Can we reduce 64 over 27? In this case, no. It's as reduced as possible. So now let's apply the strategy that I recommended. We're going to deal with the denominator, meaning the root of the exponent first, and then we'll deal with the numerator, or the power, last. Now, since the base is a fraction itself, that's fine. What you may want to think of is, and I'll actually write it here, is distribute the rational exponent to the numerator and denominator of the base. So if it helps you, think of it like 64 to the 1/3 over 27 to the 1/3. And then do it piece by piece. Let's start with 64 to the 1/3. Now remember, the denominator 3 means the cube root. What is the cube root of 64? It's 4. So we're going to write 4. And since we technically did not use the power or the numerator of the rational exponent yet, I'm going to leave the 1 there just to remind us to apply it. Obviously, it won't do much here, but it's to remind us to apply it for later examples. And then in the bottom, 27 to the 1/3 means the cube root of 27, and that equals 3. And we didn't apply the numerator of the rational exponent 1 yet, so I wrote it. But as we know, raising anything to the power of 1, you can just remove the 1 because it equals itself the base. So in summary, 64 over 27 raised to the 1/3 power equals 4/3. Let's look at the next one. We have 32 raised to the negative 2/5 power. Now, notice that we have a negative in the rational exponent in this case. And there's a number of ways that you can deal with them, and there's no right or wrong way in terms of when to apply it. There's a number of ways that you can apply it as long as you do it properly. In this case, let's get rid of the negative in the exponent first. And the way that we're going to do that is by moving this entire term to the denominator and then leaving everything else as it is. So we're going to have 1 over 32 and keep the rational exponent 2/5, and we'll apply that next. Okay, so again, now we're going to apply first the root of the rational exponent to the base, and that's root 5. So you want to think of what is the 5th root of 32, and the answer is 2. So we're going to write the 2, but we didn't use the numerator of the rational exponent yet, so keep that 2. I'm just going to draw an arrow to remind you where that 2 comes from. And now, as our last step, we're going to apply the power. Keep the 1 over, and 2 squared is 4. So 32 to the negative 2/5 rational exponent equals 1/4. And to summarize what we did, we first moved everything to the denominator, and that's to get rid of the negative exponent, which we did here. Then it became positive when the base 32 to the 2/5 is in the denominator. Then we applied the denominator of the rational exponent, which is root 5, first, and we didn't touch the top part, and then we applied that next. 2 to the power of 2 became 4, which is already under 1, and that's how we arrived at that. Let's look at my third example here. We have 8 to the 1/3 raised to the negative 2 power. Now, you could also do what we just did before, which is to move this entire thing to the denominator, and to be consistent, let's do that. Okay, so what that did was, that got rid of the negative exponent. But another thing that you could have done here is you could have distributed it, and because distributing it is really my recommended pathway to go here, I'm going to just erase this and distribute it as well so you can see 2 different ways. So when we distribute the negative 2 in, that's just doing the power to a power, which if you remember means multiply them. So 1/3 times negative 2 became negative 2/3. And now they're just combined. And now what we're going to do is, let's now once again move the entire base with its exponent to the denominator, meaning under 1. And it's going to look like 8 to the 2/3. And now, again, we're going to evaluate 8 to the 2/3 by first applying the denominator, or root 3, to the 8. And what is the cube root of 8? It's 2. But we didn't apply the numerator 2 yet, So let's make sure that we keep that. And then we're going to do 2 squared, which is 4. And once again, our answer for this coincidentally is the same as the last, 1/4. The last 3 examples are going to be a little more involved. And they come in various forms, and our goal here is to convert these and to simplify these down into rational exponent form. So let's get started. The first one is the cube root of x times the cube root of x. Now what we're going to do is, first, is convert each of these into rational exponent form. So this converted is going to be x to the 1/3 and this is the same thing, x to the 1/3. Now, this is where we're going to now apply our product rule of exponents, meaning if you're multiplying factors that are the same base, you add the exponents. And since these exponents are now fractions, we also have to keep in mind how to add fractions, and they must be like fractions. Coincidentally, these are like fractions. They both have a common denominator of 3. So this is going to be like adding x and 1/3 plus 1/3, which I'm going to show like that as an intermediate step. And then we add across the numerators, so the 1 plus 1 is 2, and we keep the common denominator 3 the same. And that's how we get x to the 2/3 for this one. Let's look at the next one, again, a little bit more involved. And what I urge you to do in this case is just go one part at a time, step by step, and we're going to convert each fraction into, or I should say, each part of the fraction and radical into rational exponent form. Let's start with this one, the cube root of 8x. So I'm just going to draw my fraction bar to delineate between the top and bottom. And what is the root? It's 3. And what is the power of the bases? It's unwritten 1. So this is going to convert to 8x to the 1/3, and I'm going to keep my 8x in parentheses. Because we will distribute the 1/3 to the 8 and the x in the next steps, and you'll see what happens. And then we have the 4th root of x cubed. Now the base is x, and we know that the power is 3. That will become the numerator of the rational exponent. And we know that the root is 4. That will become the denominator of the rational exponent. Now let's go back to the top and distribute the 1/3 to the 8 and the x. Now I'm not going to write 8 to the 1/3 and x to the 1/3, but I'm going to apply the 1/3 to the 8. And if you think about it, that's the same as the cube root of 8, which we could have broken up in the beginning if we wanted. That's another way we could have started it. The cube root of 8, or 8 to the 1/3, equals 2. And since this is x, we can't break down x to the 1/3 anymore, so we're going to leave it x to the 1/3. And then, for now, we're just going to rewrite the denominator x to the 3/4. Okay, and we want to continue. Now notice that we have a common base of x in the numerator and the denominator. And coincidentally, they both have rational exponents, or fractions. Now normally, and what we're going to continue to do here is apply the quotient rule. Meaning, since the x's are common, we would subtract the bottom fraction from the top fraction. That's the quotient rule of exponents. So for now, I'm just going to show that like this. The 2 is rewritten. The common base x is written as once, and we're going to have 1/3 minus 3/4. But if you notice, okay, when we think back to adding and subtracting fractions, the fractions are currently not alike. So we're going to have to convert them so that they are alike. So I'm going to get a different color marker just to show how we do the conversion. And we need a common denominator for each. The common denominator for each will be 12. So to convert the fraction of 1/3 to 12, we would multiply the top and bottom of that by 4. And to convert 3/4 to have a common denominator of 12, we're going to multiply the top and bottom of that by the factor of 3. And now let's write what that becomes. 4 over 4 times 1/3 will be 4/12. And 3/4 times 3 over 3 is going to equal 9/12. And make sure that you keep the minus sign. And now we can do 4/12 minus 9/12, which is going to equal negative 5/12. So that's going to be the answer. We remember to bring over the 2. That didn't change. And the answer is 2x to the negative 5/12. And actually, in this case, since we have a negative now, we need to move this portion to the denominator because we want to always give our answer in with positive exponents. So if we go down, then the 2 remains in the numerator, but this portion will go in the denominator as x to the now positive 5/12. So the final answer is 2 over x raised to the 5/12 power. And let's look at the last example here. We have 1 over x to the 8th raised to the rational exponent of negative 1/4. Now, again, we have a negative exponent. And one way that we can deal with that in the beginning is by flipping the base that it's applied to. So I'm going to apply that rule here. And this is now going to become x to the 8th. And we don't have to write over 1. It's assumed you could if you want. But putting it as x to the 8th is good enough. And now that's going to be raised to the positive 1/4. We got rid of the negative exponent by flipping this. Another way that we could have started it would be by distributing the negative 1/4 to the 1 and the negative 1/4 to the 8. But I think the way that we did it is just one step faster. And now we're going to apply taking a power to a power by multiplying exponent 8 times exponent 1/4. And you could write that out as an intermediate step, but think of 8 divided by 4, that's 8 times 1/4, and 8 over 4 is 2. I'm going to actually write it. And 8 over 4 is 2, so the final answer is x squared. So that concludes this video. And in the next video, we're going to take it to the next step, which is evaluating and simplifying more radicals with rational exponents. So anyway, thanks for watching. Please remember to like, comment, and share, and I'll see you in the next video.